Well, here we are again. Well, one more day. So today is Wednesday, and things keep changing as they always will. And so I apologize about any confusion out there. And anytime I make a mistake, feel free to call me on it. I know there was a problem with the quiz not being able to do the retake. I think I fixed that. There was a problem with the quiz even being posted. Just kind of forgot to do that. And yeah, I'm sure I'll make several more mistakes as the day goes on. Maybe we'll Oh yeah, hi Aiden. And you are first. Congratulations. You get internet points. I'll mark that down right here on the internet. So all right, where are we? First, really quick recap. As you may have noticed or may have heard, Governor Pritzker did make it official. I know it's like confusing how it works. Like, why does the president say one thing and then the governor has to come on and say the same thing or whatever? And I mean, the governor is the one that makes the rules for the state. We are the United States of America. And so the president made his recommendations. And then yesterday, Governor Pritzker officially extended the days. The day will be out till April 30th. So we're going to be doing this for a little while longer, at least another month. I don't know if I'll be able to hang on, but it's okay. Do I think we'll ever go back? I don't know. I'm expecting to not, but I won't be surprised at anything anymore, honestly. I hope we do. I don't like this, but judging by the responses I got on that survey, I don't think many of you like this either. And what I'm seeing, nobody likes this. But I guess we get to say, like, due to the worldwide pandemic, we had to not do things. And if the worst that happens to us is we have to stay inside for another month or whatever, then I guess I'd consider us lucky, because I know not everybody's going to come through this without having major life shifts. Yeah, if that's the worst that we get, I will consider myself lucky, because you never know. So I know a lot of people are dealing with this. Some people even know people who have the COVID-19. Some people lost their... I mean, there's just all sorts of craziness that's going along with this, but I don't know if we're ever going to go back. I hope so. So we will see. We will see. But we'll just keep on keeping on. And as you can see, things have lightened up a little bit for the plan for this week. Partly because of, why stress? Oh, I just did something. I think I did the wrong thing. There we go. That's what I wanted to do. I think I did the same thing over on my screen. All right. So as you can see, today being the first, I'd like you to take that quiz at some point. Make sure you're prepared to take it. Hopefully you've done the practices, all the practices except maybe practice 8. I don't, necessarily. It's fine if you want to try it. It's for a challenge, and I'll give you credit for it if you do it. There's a walkthrough here, of course, but yeah, so take that quiz when you get a chance. I made it so that you can retake it as many times as you want. Obviously, I can't stop you from cheating and saying what you get for this one. I can make 10 different versions and it doesn't matter. So I'll leave that up to you, how you want to justify your actions, but I would just try by yourself. It's not meant to be stressful, but if you did the practices, you should be pretty well prepared for it. Definitely could ask me questions. I know you might have a question about, for example, the graphs. That goes way back to the lab we did, but didn't get a chance to talk about too much. Just remember, here, let me put this here. I didn't mention it. There we go. So let me change this to not red, as usual. For a graph, when you have that's awesome graph. When you have voltage versus current, okay, if whatever the slope of the line is, that's going to be resistance. Okay, so if you have a smaller slope, it's going to have less resistance. If you have a greater slope, you're going to have more resistance. That's just how it is. All right, so that's that's a little reminder about what we didn't get a chance to talk much about with that lab, is the relationship between voltage and current and how it equals resistance. So like, kind of mentioned this, but like if you had a 330 ohm, if your resistor number was 330, that means that when you did this graph, the slope should have been 330 or close to it anyway, because that resistor number that was on the little card in the bag with all the resistors was actually the resistance of those resistors. So that's where we get the resistance, is just the slope of voltage versus current. So little questions like that, please definitely feel free to ask me. Before you go ahead and just ask each other what'd you get for this question, one of the things that we're going to take out of this, if you haven't figured out yet, is your education is definitely falling more on you. And I don't want you to worry about grades to the point where you feel like you have to cheat and copy off each other. We are trying to pare this down to the bare minimum. I mean, if that's what you feel you need to do, again, I can't stop you, and it's your own integrity. But I'm trying to go for understanding and helping you to further your education. It is obviously fallen on you a lot more than it has just a month ago. So take it for what it's worth. Give me questions if you have them. Okay. So that's the quiz. And like I said, let me know if you have questions about that. Then tomorrow, sort of a breather type thing. Somebody asked me, what about a SIP day? Well, yeah, SIP days are gone. Everything's gone. Nothing is normal right now. I don't know if you've realized that, but nothing is normal. So it's not because of the SIP day. It's more like, you know what? Let's just take a day. Let's just take a minute and just kind of chill out a little bit. You guys are, if you're doing these practices, you're working very hard at them, and they are a lot of work, especially once you get down to practice 6 and 7. And if you do 8, holy cow. And then taking the quiz is, hey, Noel, how are you? Taking the quiz is a whole nother story. And you know what? It's like, we don't need more stress of a test right this moment. So what we're going to actually probably do is, I'm thinking on Friday, we're going to start a lab. Okay, I'll put lots of question marks on there because I haven't quite figured it out yet. Okay, and that'll take a few days. And then sometime next week, we will take like some version of a test. And it'll be, like I said, it'll be just, it'll be something that we physics teachers have come up with, and in light of all this weirdness that's going on. So let's not stress about any tests or anything right now. Just take your time on that quiz. And again, don't stress about your grade. As long as you keep doing what you're doing, your grade will only go up. And, just let me know. All right. So that's it. That's all I need to say about that. So I'm going to pull this back up. So let me know if you've got questions. And I know yesterday, oh, hello, that's the key version of that. Well, that's fine. You guys got access to the key. But actually, I don't want the key version up because I want to be able to write on it. So practice 7. All right. I think somebody asked me, I know who it is, I'm not going to call her out, but, or him out, or her, I don't know. Somebody asked me about question number 3, and I could start that really quickly, but feel free to jump in with any questions you have. All right. I don't want this to necessarily just be Mr. Jern does practice problems online, because that's not really fun and exciting. I mean, not that much of this is, but let me know if you have any questions. I will definitely help you out here. So let me just add this, make it just ooh, that's a little bit too big. That's fine. So question 3. No, question 3. Are we still on the correct color? Sure, purple's great. All right. All right, draw, please. All right, let's try this again. Draw, please. All right, cool. So when it comes to these, and like I said, this is practice 7. And if you do practice 6 and 7, it's going to really practice 7. It's going to really help you like just be a master of the basics. Okay. So if you want me to go back and explain some things, I will. But this one is actually a little easier than the one I showed you yesterday. But it's definitely a good one because it's different. And it's different because it looks like a parallel circuit, and it is a parallel circuit. But inside this parallel circuit, you've got these two next to each other. Well, there's two parts that are two next to each other. So you got these two parts that are in series with each other. And so I'm going to go through and I'm going to start with the givens. So I want to let you know that even though I'm signing. Holy cow, that's so weird. Thank you, Aiden. I don't know what the problem is. I will try one more thing, and then I'll send out a remind. I will see if I can make it so you don't need to be signed in at all. But that's weird. That's weird. I will look into it. Sorry, Aiden. I know it's funny because like some people have problems and some people are seeing them just fine, you know? So it's hard for me to figure it out. I don't know what's going on, but I will see if I could try one more thing. And then, like I said, if you would like me to send you the link or the documents directly, I can just send it to you over an email. And if you want that, just send me an email or send me a remind and I can send it to you directly rather than having to click the links. You're welcome. So let's see, the voltage total is going to be our 12 volts. And then I'm just going to go like in an order that makes sense to me. 4 ohms and then 2 ohms. And then I'm going left to right, as you could tell, and then down. So 9 ohms and 3 ohms. And then 24 ohms for that last one. All right, so that's all for my givens. Now for any easies, well, there is actually an easy. Because if you know how this works, basically you have our positive 12 volts here. It's going to raise up the voltage. So everything here is going to be 12 volts. And then the jump from here, like basically every branch is going to be 12 volts. From here to here will be 12 volts, negative 12 volts. From here to here will be negative 12 volts. And from here to here will be negative 12 volts. So the battery raises it up 12 volts and then it drops 12, drops 12, drops 12. Okay. Obviously we don't know. It's going to be like, was it going to be 10 and 2? Is it going to be 6 and 6? Is it going to be what? Okay. Same thing for here. But this one, there's only one resistor. And so we know that resistor is going to be 12 volts. Okay. So we know that. That's sort of an easy, if you want to call it that. Hey, Stephanie, how you doing? By the way, if you have suggestions on how I do things, so I was just reminded for some reason. I know like taking pictures of the work and attaching them, if there's a better way to do that, or if anything that I'm doing, like if another teacher is doing it better or more efficiently, or you could just think of a better way to do things, let me know. I will look for better ways to do it. Okay. And I just randomly thought of that. But throwing that out there. All right. Oh, I forgot to do one thing. Write my equations down. So let's just start with V equals I times R. And then I could do I is equal to voltage divided by resistance. And then resistance is voltage divided by current. And then, of course, P equals IV, PIV. So, thank you. So where was we? All right, current. We got current. We got 2 of the 3. So current, I is V over R. So voltage divided by resistance. So 12 divided by 24. Wow, that's easy. So 0.5 amps. Okay. So that's kind of cool. We got that bottom one done, but that doesn't really help us, except, you know, we got one done. We don't have to worry about it. Doesn't help us with the rest. So what we have to do now is figure out, I mean, basically we got to figure out the total voltage, because then we can figure out the current and then we can go from there. So let's do the total voltage. Okay, now I'm going to change colors because I can. And so I'm going to change it to this light blue. Let's see how that works. So basically now I want to figure out the total resistance. And so these two together are in series. And so these are going to be 6 ohms for this part. 9 and 3. Hi, Rachel. I'm glad it is a good day. It's good to see you. So 9 and 3 is 12. And of course, what the number you wrote on the circuit's kind of small. Oh, hang on. And this is going to be 24 ohms. Okay. These are all negative 12s. It is kind of small. How can I zoom that? I probably can. Check that out. I can zoom in. Wow. All right. Can you see it better now? So these are 12. Will it stay zoomed? That's the question. Ooh, I don't think it'll stay zoomed. Nope. So what I'm gonna, how do I get out of zoom now? Okay. In purple. Yeah, all right. So, bloop, bloop, bloop. Let's go back to purple. It is kind of small. So let me erase those. Oh, crud. Can I? No, come back. Uh-oh. Well, undo. Well, I think I just lost it all, so oops. Well, let's do really quick. 12 volts. Where were we? This was 12 volts. I know we had all the resistances written in. 4 ohms, 2 ohms. My fault for writing. So no, it's not your fault. Hey Sam, what's up? 9 ohms. I gotta go slower here. I'm getting sloppy. 24 ohms. Okay, good. And then we had, this was 0.5 amps, because we know that from here, this is what I was writing. From here to here, to here. Because, okay, so the battery lifts it up 12, it's positive 12 volts, right? And so down each branch, this is the easies, down each branch it's going to drop 12 volts. So what I wrote earlier was that this is a negative 12 volt drop here. This from here to here is also a negative 12 volts. And this from here to here is a negative 12 volt drop. Okay, so that's what I had written there earlier. Fortunately, I didn't have much else written there, but that's what I had. And so basically what that's telling us is that we know from here to here it's 12, we know from here to here it's 12, but we don't know like how it's broken up. But we do know, since there's only one resistor here, that this resistor is 12. And so we were able to figure out our current. And I'll have to rewrite those equations up there. So, because I had that this is practice 7, bloop, number 3, and I had the equations written out. We're going to need them again. I equals V over R, R equals V over I, and V equals I times R. So, oh, and then we got the last, PIV. P equals I times V. Let's go a little slower, Jordan. Okay. So then I switched to the blue. I think it was this color blue. And basically I was saying, okay, so we're good. So then we're saying, well, okay, we can't figure out anything else. So we're just going to figure out this guy right here at the top. We're going to figure out the total resistance. And so we've got these two that are in, like I said yesterday and the day before that, you work your way from the inside out. So when you've got two resistors in series, that's an easy add. You just add them up, 4 plus 2, they're right next to each other like this. That's going to be 6 ohms of resistance for this part right here. 9 and 3 are right next to each other as well. That's going to be another one. So that's going to be 12 ohms of resistance right here. We already know this is 24, so I'm just going to leave it like that. Okay. So I'm not going to do any fancy zooming anymore. That was a complete disaster. So now that we got the 6, so this branch is 6, this branch is 12, this branch is 24. So we had to take so since they're in parallel, we had to take the inverses, add them up, and then take the inverse of the answer. So I'm going to take, in my calculator, I'll put it like this: 6 to the negative 1, 6 inverse in other words, plus 12 to the negative 1, plus 24 to the negative 1. And that's the same thing as writing, I'm just going to write it over here. It's the same thing, same as, so whoop, same as going 1 over 6 plus 1 over 12 plus 1 over 24. And if you're comfortable with working with fractions, then you could find the lowest common denominator and you could add them all up. But I don't, I mean, I got a calculator. Why would I could type it in just like that. And then I get a negative, I get a decimal, 0.29, blah, 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 blah. But what I'm going to just do then is, in my calculator, I'm just going to hit the inverse of that, and I get the total resistance is 3.4 ohms. So that is going to be good. That's my total resistance. So RT. Okay, now, big clue, is it smaller than any one of the branches? Well, I got a 6, a 12, and a 24, and this is smaller than any of those, so we are probably correct. 3.4 ohms is going to be my total resistance. All right, so far so good. Now, we can then figure out what is going to be our current. So take the voltage divided by the resistance. So I'm going to take 12 divided by that, and I get 3.5. That worked out kind of nicely, strangely nicely. Yep, 12 divided by the answer, 3.5. So now I know the total current. So I know the current going from the battery is 3.5 amps. Okay. Now that 3.5 amps gets split up. Some of it goes this way, some of it goes this way, and some of it goes this way. Well, we already know that 0.5 amps goes down this way, 0.5 amps. Okay, so now what? Well, here's what we know. This is where you might have stumbled a little bit. Like, how do I go from here? Because I don't know. Like, what do I do? Well, think of this entire, like these two branches, think of it as one big 6 ohm resistor. And think of this branch as one big 12 ohm resistor. We know that there's 12 volts across this whole branch of 6 ohm resistance. We know there's 12 volts across this whole branch of resistance. So if we treat it like that, then we can calculate it. So in other words, come on, don't do this to me. My pen disappeared. Pen. Okay, so that means for this branch right here, I know that the resistance is 6 ohms, and I know that the voltage is 12 volts. So in other words, I could figure out the current going through that branch, going through both of those resistors. So current will be V over R. So I'm going to take 12 divided by 6. And so that means the current going through here is 2 amps. So I could say this is 2 amps going through both those resistors. So I'm going to say over here 2 amps for both of those. Now I'm kind of on a roll here, so I could go ahead and stop and figure out voltage, but let's do that again, except now for this branch right here. I know that the total resistance is 12 ohms. I know that the voltage is 12 volts. And so with that, I could figure out the current. And so current is going to be V divided by R. So that's kind of an easy one. 12 divided by 12 is 1 amp. So I know that going down this way is 1 amp. And so I could put that right here. And that's going to leave me in a good spot. But let's just look at this to make sure. So we got 3.5 amps coming out of the battery. Doesn't make sense that 2 amps goes this way, 1 amp goes this way, and a half an amp goes this way. That adds up to 3.5. So we're good. Okay, because those are going to come back together. The half amp is going to come over here. It's going to join with the 1 amp, which is going to join with the 2 amps. It's going to add back up to 3.5 amps. So the math checks out, so to speak. Okay, but it was that this part right here that you probably got stuck on. Okay, if you didn't get stuck up to the rest of the point, it's this part where we got to realize, oh, we got to treat this as one big resistor and figure out how much current is going through it. And after that, you can figure out the rest. Okay, so once again, this is one of those things where if we had time in class, we'd spend more time on it. I could walk around the room, I could help you out individually, and you'd get it, given that time, given that situation. But as it is, consider this just like I said yesterday. If you're in a sport, when you do practice, you practice harder than you do when you're going to play the game, right? So you practice hard so that the game seems easy or easier. So that's all this is. So this is a good practice. I'm going to give you credit for it. I'm going to give you points for doing it. I won't take away anything if you don't do it, but it's practice for the big game, which is going to be not this difficult. All right. So I'm going to go ahead and figure out those voltages, which is I times R. Well, I guess I don't really need my calculator. So now I've got these, and I could just go ahead and figure out all these voltages. So V is I times R, so 2 times 4 is 8 volts, and that would be 2 times 2 is 4 volts. Those two together add up to 12. which is good because those are those two right here. And 1 times 9 is 9 volts. 1 times 3 is 3 volts. And those two together add up to 12, which is these two resistors right here. Okay. Now, if you go take electricity, take, you know, some, even an AP physics, I don't think you go into this too much. If you go on further with this, this is, if you take my engineering class, the second year of the principles of the engineering. So if you have Mr. West this year, you'll have me next year. So I don't know if you knew that or not. Those of you who signed up for principles of engineering, that's me. We'll do this again, but it'll make the second time you hear it, it'll make a lot more sense. So then I just multiply I times V. I don't even know if I'm going to, well, I'll do it really quick. Why not? If you got questions, throw them at me. It could have to do with this. It could have to do with anything. All right. The question could have to do something about that doesn't. All right. The questions can be about anything. You could ask me about whatever you want, but meanwhile, I'm just going to finish this off, and because it's easy for me now. So I times V, so 12 to, all right, I can't do that. Well, I probably could, but I don't want to. Times 3.5. So 12 times 3.5 is 42 watts. So that's how much the total should add up to be. Everything's going to be using up energy. Everything's going to be giving off a certain amount of energy, using it up. So it should all add up to 42 when we're done. So V times I piv. So 8 times 2, I can do that one. 16 watts. 4 times 2 is 8 watts. 9 times 1. It's tricky. 3 times 1. And 12 times a half is 6 watts. So let's just double check. 6 plus 3 plus 9 plus 8 plus 16 gives me 42. So that is question 3. All right. Anything else? Anything else? What else? It was nice to see you guys in the Zoom. Those of you guys who showed. I think I might do that again next week because, you know, it wasn't a big group or anything like that. Maybe I'll. No, I don't think I'll combine them. I don't know. Maybe I'll combine them. Maybe I'll try 1 week combining the 2 physics classes, and maybe I won't. I don't know. I'll make this up as I go. But yeah, if you need anything, let me know. Respond to that survey. Many of you have already sent that out. Just kind of like, you know, I don't get to see you, so I don't get to see how you're doing. But let me know. Let me know how you're doing. Let me know what you need. If I could do anything for you. Otherwise, that's all I have. So throw questions at me through the Remind. Send emails. Keep doing that, and keep pointing out all the mistakes I'm making and anything I could do to make it a little bit smoother for you. That's my main goal. Okay. So you guys take care, keep being safe, keep staying away from people. And honestly, Noel, I don't like I said at the beginning, if this is the worst that I get, I won't complain and I'll be happy about it and I'll consider myself lucky. So far, we're all healthy. It's a little boring sitting inside all day. I do get to go outside every once in a while, but it's fine. It's fine. But yeah. How about you? You guys who didn't make the make it to the Zoom the other day. Hopefully next week you can. All right. But yeah, no, I've just been doing this stuff, sitting at the computer, grading stuff, answering questions, going to meetings. Not too much. Playing Animal Crossing when I get a chance, Minecraft when I get a chance. I haven't had a chance to stream anything yet. I don't know if I will, to be honest, because that's not as relaxing, but we'll see. We'll see. Just doing what we're all doing, just getting through this. And it is temporary. We'll be back eventually. Okay? And then we're going to look back on this. Did you? How does that work? I imagine that had to be online. But yeah, that's good. I mean, it's kind of cool. There's all sorts of like websites and all that. I mean, if you haven't, it's something to look into. If you like playing games, you know, whether it's D&D or card games or anything like that. I mean, it was kind of funny. Like if you can, talk to other people online as you can, if you feel the need to, if you played. But if you could find games like that to do, to keep, to talk to others. Yeah. We played Pictionary online with my family over the weekend using Zoom. It wasn't perfect, but it was nice to see everybody. My family who lives in my since I'm a grown up, they all live not with me anymore. Oh yeah, I've heard of Roll20 before. Yeah, good. I mean, we need that, so that's why I do the Zooms, because it's good to see other people too, whether even it's a school. So we do what we can with this, right? And like I said, if the worst that happens is that we're bored and we really want to go back to school, consider yourself lucky. So it will end, and hopefully we'll come out at the other end stronger, but we will see. All right, well, I'm going to end this. You guys keep reaching out to me, keep talking to me, and have a good afternoon. See you later.